Alright, I'm going to be covering problem number 42 in chapter 4. And the problem is as follows. A 6.50 kilogram instrument is hanging by a vertical wire inside a spaceship that is blasting off from rest on Earth's surface. So just draw that. Just imagine that just kind of being the top of the rocket. And we'll draw that, and we'll have this be our instrument. And that is 6.50 kilograms. Resting off from rest of the Earth's surface. This spaceship reaches an altitude of 276 meters in 15.0 seconds with constant acceleration. Part A. Draw a free body diagram for the instrument during this time. Indicate which force is greater. So first, let's just get our instrument. We'll just have our instrument be this dot right here, this point mass. Okay, and it says draw the free body diagram of all the forces that are acting on the instrument at this time as the rocket accelerates upwards. There's only two forces acting on the object. There's the weight of the object, force of gravity, but then we have the tension of the wire, which is keeping it in place. And it says indicate which one's bigger, and tension is bigger than weight. Because we know that the object is accelerating upwards, it's moving upwards. So this one has to be greater than that one in order for it to accelerate upwards. So these are this is the free body diagram for the object. You have the weight pulling down, the tension like pulling it up. And now for part B. Where we find the force that the wire exerts on the instrument. So first let's set up so we can do this by using Newton's second law. So let's do the sum of the forces on the instrument is equal to, so let's have up be the positive direction, is equal to T minus the weight of the object, which equals MA. Alright, so now we have so we have an unknown here. So quickly, if we were to solve for T, it would be MA plus W. And so we have the mass of the object, and we can calculate the weight easily by just doing mass times acceleration due to gravity. But now we need to find the acceleration of the object. And we can find that acceleration of the object is going to be the same as the acceleration of the rocket. It says the rocket is at constant acceleration. We can find that using the information given to us. So it says here that the rocket reaches an altitude of 276 meters. So we're going to use a kinematic equation. We're going to use height equals 1/2 AT squared. And the rest of the equation would be like V initial plus X initial, though both of those are 0 because it starts from rest from the ground. So we have that. If we quickly solve for acceleration here, it would be 2h divided by t squared equals a. So then we just move that down here. M equals times 2h over t squared plus mg. Okay, and if we were to plug in all the values that are given to us, plug in the mass as well as the height, travels to a height of 276 meters, plug it in there, and it takes 15.0 seconds, so just plug that in there, and plug in 9.81 for acceleration due to gravity and mass of the object. And after you plug everything in, answer, keeping track of stick figs, the tension equals 79.2 newtons. And again, what's going on here is the tension is greater than the force of gravity, and that's why it said to accelerate upwards. Like if you're just looking at this object, you're not going to be looking at the acceleration of the rocket, you're looking at the acceleration of the object. So you're just like, just imagine if it's just like something is pulling it up, like the tension is just the force that's pulling it up, and then that force has to be greater than weight in order for the object to be accelerated.